So we are going to look into differential calculus, which is
Mm-hmm.
very, very important for IBSL, obviously for
Mm-hmm.
HL also. Now let's say we have been given one function y is equal to fx, and we want to differentiate y with respect to x. This can be written as dy by dx. So we will not cancel out d and d, because dy by dx, it is the symbol. Basically, it should be written like this: d by dx of y. This is the actual writing process. So we are differentiating y with respect to x. This is also written as, it can be also denoted by f dash x. So this dash
Mm-hmm.
represents that we are differentiating f with respect to x.
Yeah.
Now,
Okay.
differentiation has certain rules. So this differentiation is itself is a mathematical operation. Every
Yeah.
mathematical operation will give you certain value, certain result. So this differentiation should also give us some result, is it not?
Yeah.
So let us look into this. If we want to differentiate a function with respect to x, we will get another function. So this function we should know. Most of the basic standard formulas we should memorize, and rest we have to derive, or rest we can easily do it while
Mm-hmm.
solving a particular problem. So what are the rules? So let us look into some of the standard rules of differentiation. First of all, if y is equal to x to the power n, where n can be anything, n can be fraction, but n should not be any complex number. So n should be real number. It can be anything. Then,
Okay.
so if we want to differentiate, so we will write dy by dx is equal to nx n minus 1. How it is
Mm-hmm.
coming, we can derive all these things using first principle of differentiation. So that topic we will do later on. So here, if y is equal to x to the power n, then differentiation of y with respect to x is given by nx n minus 1. For example, if we have been given y is equal to x to the power 5, then dy by dx will be given by 5x to the power 4. Okay. Then similarly, if we have been given y is equal to root x, that is x to the power 1 half. So dy by dx will be given as 1 half x 1 half minus 1. That is 1
Mm-hmm.
half x negative 1 half. That is 1 by 2 root x.
Mm-hmm.
So whatever question we have been given, we have to just convert it into this format, and then we can write dy by dx.
Mm-hmm.
Okay. This is the first rule. Let us look into the second rule. Second rule is, if y is equal to any constant and we are differentiating y with respect to any variable, and this variable is not present in the function of y, then dy by dx is equal to 0. For example, if we have y is equal to 5 and we want to differentiate y with respect to x, that will be 0. In fact, anything, let's say if we want to differentiate y with respect to some other variable, and if this variable is not present here, then this will be 0. This is
Okay.
important. Okay. Then coming to third rule or next rule. So y is equal to sine x. So if we have y is equal to sine x, then differentiation of y with respect to x will be cosine x.
Mm-hmm.
Then similarly, if we have y is equal to cos x, then differentiation of y with respect to x is minus sine x. Remember, here negative sign will be there. In integration, we will see this negative sign will become positive sign. Then next is, if y is equal to, let's say, sin x cos x, that one. If y is equal to e to the power x, then dy by dx will remain same. Remember, for exponential function, differentiation will remain same. It will be e
Yeah.
to the power x only. Now, what are the other rules? So other rules are, it is 5, okay. So if y is equal to log x, it can, if y is equal to log x, then basically ln x we will write. If y is equal to ln x, then dy by dx is equal to 1 over x. Then next one, if y is equal to, uh, if we have any constant, let's say k multiplied by fx, where k is a constant, then if we want to differentiate y with respect to x, then k we will keep outside and we will just differentiate fx with respect to x using the previous rules.
Yeah.
For example, uh, we have been given y is equal to 5 sine x plus 7 x. So now if we want to differentiate this, then we will take 5 outside and we will differentiate only sine x, which is cos x, plus we
Mm-hmm.
will take 7 outside and we will differentiate x, which will become 1. So it will be 5 cos x plus 7.
Yeah.
Then there are some operations related rules, like if we have one function which is composite function, which is simply sum or subtraction of two different function. Now, if you want to differentiate y with respect to x, we have to differentiate y1 separately, put plus or minus whatever sign it is, and then differentiate y2 with respect to x. For
Mm-hmm.
example, if we have y is equal to e to the power x plus log x, so we will do dy by dx is equal to ex plus 1 by x. So this is
Okay.
log base ex it was. Okay. Then now coming to one of the important, very, very important rule, that is product rule. This is very, very important. So product rule says that if we have one function which is product of two functions, then
Yeah.
these two functions are function of the same variable. Then if you want to differentiate y with respect to x, then we have to write y1 as it is and differentiate y2, the other function, with respect to x, write down plus and differentiate, then write down y2 separately and differentiate y1 with respect to x. So
Yeah.
what we are doing, we are differentiating y1 and y2 one after another, keeping the remaining one as constant. So in first term, y1 was constant and we have differentiated y2 with respect to x. Then in the second term, y2 is kept constant and we have differentiated y1 with respect to x. And if between these two terms, we will put plus. This is extremely important rule which will help you later on. So let us look into some question based on that.
Yeah.
See, let's say we have been given y is equal to x square sine x. Now we can see that it is product of two functions, x square and sine x. So now if we
Mm-hmm.
want to differentiate y with respect to x, what we have to do? We will take x square outside and we will differentiate sine x. Then we will put plus and then we will put sine x outside and we will differentiate the earlier one, that is x squared. So it will give us x squared, sine x will be cos x. So x squared cos x plus sine x, and differentiation of x squared is 2x. So now rearranging it, we will get x square cos x plus 2x sin x. This is the differentiation of this. So we will see many questions based on that after this lecture. And then let us look into another important rule which is called division rule. That was called product rule. Now we have one division rule also. So division rule says that if we have a function y, which is division of two function fx and gx, given that gx is not equal to 0, otherwise this y will become undefined. Now, if we want to differentiate y with respect to x, a rule is the denominator will be simply squared. Whole denominator you have to write squared. Then you write down the denominator function multiplied by differentiation of fx with respect to x. Then put minus sign. And then you keep fx, that is numerator function, as it is and differentiate the denominator function here. This will give you the dy by dx. So this is also very, very important because it helps us in solving the problems much faster. Then we will see one example of division rule. Let's say our question is y is equal to x square over sine x. And we want to find, so question says that find dy by dx. So what we will do? We will differentiate y with respect to x. So now using the division rule, we will first write down this sine x here. So sine x whole square. And here we will write sine x. We will differentiate x squared d by dx of x squared. Then we will write minus. And we will put x square outside, which we have differentiated earlier. And we will differentiate the term which we have kept outside, that is differentiation of sine x. If we do this, right, if we do this, we will get sine x 2x minus x squared cos x by sine square x. Now we can simplify it also if necessary, we can simplify it. Otherwise, we can just keep it as it is. So this is the division rule. Now we will look into the chain rule, which is again one of the most important rule. So chain rule, it is used for composite functions. Means when one function is embedded inside another function. So chain rule is very, very important. So let's say we have been given y is equal to f function within another function. And now we want to differentiate y with respect to x. So what we will do is, we will go on differentiating the functions with respect to their variables. Like our bigger function is f, so we will differentiate f with respect to g. Then multiplied by differentiation of g with respect to x. Say for example, if we have been given y is equal to sine x squared. So now we can see that sine is a bigger function and x squared is the smaller function. So we will write dy by dx is equal to, what we will do is, we will differentiate this sine function, the bigger function, with respect to its own variable. So its variable is x squared. Multiplied by, then we will differentiate the denominator part with respect to x. So this one will become cos x squared and this one will become 2x. So our answer is 2x cos x squared. The interesting part is this chain rule can be used for any number of functions. Means if we have multiple functions, more than multiple functions embedded into each other, then also we can use this chain rule. Okay. So these are some of the important rules of differentiation. So now we will do some practice and then again we will see some other kind of rules, some specialized rules to tackle the differential questions.